Our next speaker is Laura Edell. Edell, like the speaker, like the singer. And she's chief data scientist at a little company called Microsoft. She gets to hang out with cool people. I know I saw Mark Tabladillo. I know I saw you somewhere in here. Yes. She gets to hang out with several cool people that I know that work at Microsoft. And she's also a fellow podcaster. She spent time at Apple, where she helped to build Siri Generation 1, pretty impressive. She also happens to have a master's in quantum physics, and we're thrilled to have her again at SDSC. Her podcast is called Annie-lytics, Annie like the girl's name, and so that's the word that I have for her today. Welcome, Laura.
When I looked up fun things to do at a conference, it said, mingle with the guests, be in the audience. This was not planned. I had to get lavaliered, so I'm coming. So I'm very excited to be here today. My son started school, and so I'm actually Zooming with his classroom. So I'm going to start this really quickly. If we hear feedback, then I'll stop it. Hopefully we won't. Nothing like technology. All right. So I wanted to talk to you today about reinforcement learning. So it is the exact opposite of simplicity. So if you walk away with anything from this talk, it is going to be to compare the previous speaker and I and say, complexity, simplicity, which I loved your presentation, by the way. As Beverly mentioned in the intro, I'm very passionate about women in tech, girls who code, girls in STEM, and helping the next generation. And so that's really what my podcast centers on. And so it's one of those things that started as a labor of love during the pandemic and has just grown. It's just an amazing experience, and I'd love for you guys to check it out. And if there are any women or allies of women in the audience who would like to come on, let me know. Sorry, shameless self-plug. All right, so I know we've all seen this picture before, but I literally have a dog who I wish looked this cute. Kind of has eyes that go in different directions. And the very first time I saw this, I was looking at the blueberry muffin going, that looked like my dog, and I had to look close enough like, oh wait, that's a muffin. And so, one of the funny things about, when we're looking at the human behavior versus, say, machine learning, or in this presentation, reinforcement learning, is that, can a human do it better, or what is that baseline, and what can we do above that? And if we can't, then maybe it is too complex for the use case. And that's one of the things I've learned, really the hard way. I always want to jump to what is the next greatest fill in the blank. I think I tend to probably make things overly complex. I am a quantum physicist, so my degree is literally in theorizing a world that we don't actually know any of these things that I've studied exist, but it's in theory, and that's fun. But it does make it a little bit complex when it's not so black and white. So I asked my son, I'm sorry to keep talking about my son, but since his classroom is staring at me, I asked my son to sit down with me so I could try to explain, what reinforcement learning was to a 10-year-old. And pre-pandemic, the president of my company asked me to explain to her what machine learning was as though she was a 5-year-old. So we've grown 5 years now. And so I sat down, and it was actually a lot harder than I thought. And so I sat with him and I said, okay, you need to find yourself a reward function, or we want to find or learn a reward function. What is going to help motivate you? And, what is that goal going to look like? And so as we sat down to that response, he said he wanted a mango. And I said, okay, you want a mango, but we only have apples. And he fought me on this, saying this apple was a mango. And I don't know, we went round and round. And I was like, oh, interesting. We've created this loop here now. And so by the end of it, He literally had to cut it open, taste it. I'm sorry if I'm embarrassing you. And then he was like, oh, it's an apple, as though I didn't know this was an apple. But it was an interesting sort of experience to see, how passionate he was going into this thing where he wanted the fruit. That was his reward function. He wanted to be able to eat it, yet I wasn't going to let him eat it until he played this game and got it right. And so that became our loop here of what this sort of explain reinforcement learning to, a 10-year-old is. There was a response that I was desiring. There was an end reward function that I wanted to be able to determine, acting as an agent. And, I wasn't going to basically allow us to score that reward until it was a value that we were looking for. And so this presentation I wanted to walk you through today is going to have a lot of real-world use cases, because one of the things that I don't know if you know me or if you've ever heard me present, I'm very big on breaking stuff down into real-world examples using real-world speak. And I think one of the most complex things is, explaining something like reinforcement learning, saying something like, this is a general framework for learning sequential decision-making tasks, and then comparing it to something like deep learning, on the other hand, where you have representations and combinations of models and best answer. It just gets super, super complex. And instead, I think when you break something down into its most simple form, you've got an environment in the real world. That environment can be gaming, can be the environment of a game that you're playing. This environment can be, maybe it's day trading. You've got some type of environment that you're working in. I've got a ton of examples from a marketing perspective around slots on a website. You want to know, if I'm going to place a certain item on my website, is it more effective to have it above fold, less effective? And can I quantify that when I'm looking at my, users engaging with this website? For many years now, we've done things like A/B testing, but reinforcement learning becomes very powerful to be able to, look at that website, look at, the behavior of your users, and then let it dynamically shift and change content based on what they're doing. I think if anything that the pandemic taught me, at least, was that binging Netflix has gotten to a point now where I've literally run out of things to watch. I was down into probably 9-fold of shows, and I'm like, I'm really not going to do anime. I'm doing anime now. And that's where I'm at. And so I think I'm on Demon Slayer season 2. I don't even know what. It's actually really good. But, all through the pandemic, that was always our remote icebreaker. What shows are you binging when we would come on? And it made me think, about the early days when we were building Siri. And at that time, Amazon had the gold box. If anybody is here from Amazon and you were here back then, I apologize. But I remember I once bought my uncle a Husqvarna chainsaw. Now, I'm not stereotyping myself, but I am not a Husqvarna chainsaw girl. This was a gift I was giving. I clearly had no pattern of ever buying power tools, but from that point forward, my gold box had recommendations that were power tools for I don't even know how long. And it was so frustrating. And I remember sitting at Apple going, this has got to be something that we can fix. If we're going to have people engage with Siri, let's make sure, and of course, I'm talking about NLP there, but can we augment what we're doing with NLP so that it's a little bit more human-friendly, that we are rewarding the right behaviors and learning from them as we go? It should be able to tell that my pattern of searching and buying one time and one time only was power tools, and everything else was shoes, clothes, food, vegetables, whole foods. Everything else you can imagine, but not that. And so what's great about that is I think about the early days of Netflix, and I think about the early days of, Amazon or different shopping sites. And if you think about it in terms of reinforcement learning, you can see how we've grown in terms of the dynamic ability for us to represent our changing desires, and how we engage with these sites, how we engage with the environment as the agent that we do. And so, when you think about the real world, I think a lot of people think about autonomous driving. That seems to be where everybody sort of stops. But I wanted to get a show of hands of the folks in this room. How many of you are actually doing something or exploring reinforcement learning today? I'm always the one that's like really ahead of that curve. Last time I presented here, I was all about sound ML, and I'd had my son do some sounds, and I'm like, can you guys guess what this sound is? And it turns out it was a broken air conditioner, and no one could guess, but it was actually my son going, anyways. So that's interesting. So to me, I'm seeing all of the different customers represented, or sorry, they're customers to me, companies. I'm just curious, is it something where you guys are not exploring it yet because you are fully adopting machine learning? Is that why, or you're looking to embrace it maybe in a few years? I would just love to get a sense of why the larger majority of you are not. Is anyone brave enough to sort of stand up and sort of tell me? I promise you I might have swag. All right. No, you can sit.
I continually try to go back to reinforcement learning and apply it. And my domain is NLP of like student writing, student essays, and research papers primarily. And every time I go back to it, I don't see stuff for the traditional machine learning metaphors that we think in, where we think more in terms of representation learning and then classification, progression, and whatnot. Reinforcement learning has a whole different set of metaphors, and I don't see much material bridging the gap between the metaphors. And then furthermore, the entire process of optimization and the entire performance profile in production of a reinforcement learning model versus traditional, or not traditional, but like deep learning model
Yeah.
is a whole different set of concerns that need to be learned separately.
So let me, just to follow on that, as you went through the pandemic, and as many of you probably realized, the data sets. Sure.
Thank you.
What I was asking was to understand why more people aren't adopting reinforcement learning today. And, and I'm sorry, what was your name? Marcel. Marcel was brave enough to answer, and basically the gist, if I've captured it correctly, was, we're in a paradigm of machine learning when it comes to, a set of, terms that we're used to and engaging with when it comes to production models. These are things, from a supervised perspective, we're used to classifying and labeling, potentially even unsupervised. I don't know the types of models that you're building, but there's challenges that come with that, and then even more challenges when we start talking about deep learning and, that series of algorithms. And so I think to your point, a lot of people have a stepwise notion of, I'm going to start, it's kind of like when I was at Apple, I remember people talking about reporting. And I remember somebody brought me this book of like 1,000 pages, and they're like, oh, every page of this needs to be on a dashboard. They're all equally important. And I just remember sitting back like, that's ridiculous. The CEO only cares about like 5 things. But they weren't, they weren't ready for that. And they evolved to the dashboard. Then they evolved to sort of their baby steps into, predictive modeling, machine learning. And really that's where we are today. Let me ask you though, when the pandemic came, did you find that, and I don't know sort of your research side of things, but that a lot of data sets became truly, non-usable? They were historically based on a world that we no longer, lived in. Everything was different. So whether it was supply chain, whether it was healthcare, things were different. And then how would you address that? It's incredibly expensive to rebuild training sets. How did you, approach that, or did that affect you? Oh, interesting.
On the types of tools that were available. So you have various machine learning models online and very easily accessible to students via pretty UIs, where they can just have whole essays generated. And
That's true.
How do you detect that? The answer to your question is we just tediously create new data sets based on whatever we have and then human evaluation.
And so I think, to that is a beautiful example where there's a cost to that, and that opportunity cost may be worth it, in, especially in an academic, frame. I was playing around with some of those AI tools to, on my podcast, I took a script that we were going to do and I plugged it in and I said, okay, now I want it to be elegant. Now I want it to be concise. And it was super fun, but I'm like, wow, I can imagine if I'm going through school that this is something that, is going to give, an advantage. But I guess then playing devil's advocate, is this something that we should fight against, or maybe realize it's there and embrace it and find a different way to do things? And I think that's really where reinforcement learning comes into play. And so one of the great examples, I think, outside of gaming and autonomous driving that I found really interesting was the GameStop day trade short. It was very interesting to me how many people suddenly became day traders, and jumped into this world that weren't traditionally from the finance sector. It made me get excited, and I was like, oh, I'm going to get Robinhood, and I'm going to do something here. And I started exploring it more and more, and I realized that there's this power of, let's say, social community that is different than we've had in the past. There's this swell that community brings. And what I think that's important is when we look at things like what happened with GameStop or in the manufacturing sector, something very near and dear to my heart is when we ran out of N95 masks. There was a slew of additive manufacturers that had prototypes and patents to print, 3D print masks. The government and FDA had, made regulations a lot simpler, but there was no way to connect, let's say, ma and pa hospital provider in Kansas with additive manufacturer X, over here and wherever, so that they could then meet in the middle and have that supply chain gap filled. And, to me, that seemed like this amazing opportunity where, additive manufacturers have all sorts of different inputs and source materials to build things that we don't even know about, but it's that connecting of the dot. It is that community sort of bringing together of those points that I think becomes really relevant if we think about more of the reinforcement learning in the real world. Same thing with inventory management. We've heard a lot about, I think, supply chain shortfalls are still happening. I live in Charlotte, North Carolina, and, I've gotten used to, when I Instacart something, probably 90% of the stuff I order, even though it says it's available, is not available, and they're having to swap it with something else. And we've just accepted that's okay. That is the new norm. But should it be? And these are the things where these stores, these grocery stores are using legacy systems, legacy data sets to predict what they need on the shelves, and clearly they're not either being able to find the goods to be able to sell, or their data sets are outdated and they don't really realize the trend of what's happening. I don't really know if there is a retail grocer in here. I'd love to know more about it. But that is where reinforcement learning can come into play. It is a whole new paradigm where, as I'm in Instacart changing my behavior, so for example, I get on these kicks of stuff. So I'm a vegan, and I find particular things that I love, and so if there's like a new type of fake burger or whatever it might be, I will go in and I will go in deep for like a week, 2 weeks, sometimes 4 weeks. And then my grocer, I'll see, will start stocking it. And then I'll get tired of it. And then it goes on sale, and then they're having to sell it 2 for 1. And I always wonder, I know it's not me, shifting the markets, but again, it goes back to, they have a data set that is clearly not following my pattern, or following the pattern of their consumer. And so I think, these are just some, examples that I wanted to share with you that are sort of different than the autonomous driving only and gaming, although I'm going to, go into depth in some of those examples. But I think it's interesting thinking about, some of the other use cases that we have here around this idea of decision AI. And so, when we think about reinforcement learning and multi-agents, not one agent, one decision, and I'm going to show you an example. My son helped me record here in a second. But decisions aren't made in a vacuum. They're not a point-to-point decision. I'm making a decision that says, I'm not going to go to the store today. I'm going to use Instacart. And in Instacart, I'm going to get these things. These are hierarchical decisions that typically pick up one after the other. Sometimes they don't. But they typically require multiple decisions to happen, and adaptation to occur as I'm going. And that's, traditionally what a lot of reinforcement learning models are getting to, but it's a huge cost when it comes to data. When we're trying to determine that reward function of a multi-agent, as you'll see in one of the next slides, there's a huge cost when it comes to actually computing that. And to be able to simulate that at scale in the production world, there is a big cost to it. And so it goes back to that opportunity cost of saying, in a production world, is the cost greater to have a different training set, to invest in that mechanical Turk, let's build a new data set, and let's train with that, or let's invest into the compute cost to be able to run these more advanced algorithms, like a multi-agent or a multi-slot in the website example. And so, let's move forward here. Okay, so this is the, oops, let me go back. This is the example that, I don't know how to actually, how do I hit play on this? Like a click? I can hear me back there. So I wanted to, do something very simple here to sort of walk you through an example, just a very simple grid world. I'm not sure how to make it play. Does anybody know how to use this? Quantum physicist and all, but this is a bit complex. I can pretend. All right, so imagine our coin here. We're going to call him Frank. And you have a grid. So we're working in a grid world here, and you have to learn a reward function. None of us in this room know what I'm expecting from this model. So you need to learn what is considered good or not good to do. So in this instance, we need to be able to control the agent, and we're going to call him what his name is. I don't know why it's a he, could be a she, could be an anybody. And so when you're taking this coin, there is a set of steps, and we want to get to green. So in the video, there's all sorts of little sound effects my son does, but I'll save you from that here, although I just did it anyway. So if I were to ask you, just looking at this, what are some inferences you can make without knowing anything else other than we need to get from where we are with Agent Frank to green?
Can't go in the red boxes.
Can't you? So it's a great assertion, but there are some white boxes above, so it sort of tells you you can or can't, because you can get around them. Now, orange, on the other hand, there's no way to get past orange. So that would tell me there's something to do with orange. Now, if you saw the video, you would see me explicitly avoiding blue. And so, again, an inference would be that, blue is something we want to miss. Red is something that we can choose to either go through or miss. Again, we're looking for the optimal path to get to green. And of course, orange is something that you cannot avoid. These simple inferences are examples of where, when you're trying to learn a reward function and what's good or not good, it's sometimes just as important to know the exact rules or path as it is to not know and to learn and to have that cycle as you go. And that's where, in the example of Netflix, in the example of the Amazon Husqvarna that I led off with, that is where, as you're learning, that Husqvarna would not be a reward function that I would score. Let's say out of a 0 or 1, I would give that reward function a 0. In terms of my long-term gold box, this is who Laura is. Now, in that moment, that point in time, obviously I bought it. But in its, determining of it being a reward function, something meaningful, it isn't. And that's where you have to be able to make these inferences. And that's the power of, in this instance, a maximum likelihood inverse reinforcement learning. It's going to allow you to have the power to, run through this cycle and figure out, is blue bad? Is blue good? Now, if you'd seen the video, you could have made that assertion. We know that, orange is something that we cannot avoid. We don't know why. But one of the bigger questions at the end is, well, what do we do when we get to green? That is where, is this something where, it's just a one and done? Meaning, if we had done the Husqvarna world, it's one and done. I bought that thing, and now it's always going to be associated with me. That's not really a very smart agent. And that is where, in the maximum likelihood, you have to be able to make these types of inferences, but be flexible enough to look at both what the inference, but also what the inference isn't. It would have been a really great video with lots of little kid, but anyways. And so, just in summary of what that might look like in terms of more of an informal, definition, we're looking at these state representations of these tasks, and we're looking at both the reward and the best action. And so in our path, we don't actually know, going into this, what the best action is. We know nothing. It's just like the example I showed you at the beginning with my son, where I want him to, have this fruit, but he's got to go through this path of, what is this fruit? It's not an apple, no matter how hard you fight me. It's a mango. And until you get there, you're not going to get to enjoy this mango. And you're going to go through that loop, and finally you're going to come up with some inferences that say, okay, this is not as hard as an apple. This is not the same color as an apple. I'm going to make some judgments about this thing. I think he was particularly being difficult, but in that world where it's a much more challenging task, you're going to have to solve those domains to actually understand those real world problems. And so, okay, let's think about it in terms of, rock, paper, scissors in the same way. Now, we have a rock, paper, scissors. That's, our agent to start with. But there is an actual multi-agent at play here, because the rock beats a scissor, the scissor beats a paper, paper beats rock, repeat. Well, over time, that behavior, that cyclical behavior becomes your multi-agent of where you're starting with. And if you're like me, I will sit and stare at somebody deep in the eyes and swear I can predict what they're going to do next. If you want to, test me out there, come at me. I swear I'm a master of this. But again, this is where you have more than one decision that has to be made at any one time. You can't just lock on and say rock and think about nothing else. You need to think about things like, well, what did they throw last time? How many times have they thrown this? Is there something that I can pick up from this behavior that they're doing? Does scissors beat rock? Does paper beat scissor? All of these become decisions in that inferencing that you need to make to be successful. Now let's look at it in a little bit more complex personalization of content example. In this instance, we're looking at the multi-slot learning. And I know we're at 5 minutes here. So we want to be able, if any of you have an Xbox, you'll know that the content dynamically changes all the time within your Xbox homepage. And we're doing that through what we call multi-slot learning. These are just conditional contextual bandits that take up the slots and basically rank content by the topmost action that can be learned and ranked based on what you do and what behavior you do when you're on your Xbox. So for example, when we're trying to sell a game that isn't selling very well, we will place it in a certain slot within the particular frame. So you think above fold, has 4 or 5 different slots. Well, just because it has 5 slots, each one of those has a different ranking that makes it the most important class for that action. These slots are very specific, very sequential to the behavior that's taken. So if you go in there and let's say you click on, top left, which is the primary slot, prior to clicking on anything else in here, what the system will do is it will associate a reward to it. That is the slot we wanted you to click on. If you are logging in and you are seeing your friends list or friends you are not friends with for the first time and you click on it, we will associate, again, a reward function to that because that is the behavior we want to drive. We will repeat that in every time you're going through this because there is a value to be associated with placing those slots consistently and personalizing it in its totality. So it's not just about one, it's about the entire frame that you're looking at. And so again, it's about learning that top action and then ranking it by its importance, taking Husqvarna and sort of demoting it from its importance while promoting the things that are actually important to me. And so this allows you to have both shared and very specific features associated with those. And it allows you to, make decisions chosen for that slot, but again, in its totality. So if you think about a website and you think about, where, now I encourage you when you go and look at a website, when you leave this session now, think about what's placed where. Think about where Google places search results. Any website that you use. I am not a social media person, so I can't, use the power or what they do with social media. It's like a Jedi mind trick to me. But it's very powerful in terms of the behaviors that they elicit because they use the power of this multi-slot, multi-agent concept. And so for us, I know this is very small, but it's an architecture diagram to help explain to you, what benefit you get out of doing this from a financial perspective for those of you that are interested. And again, coming down to sort of the end of this, I think the net of this all is it's not about reinforcement learning in its island on its own. It's about taking the machine learning, greatness of stuff that we already do and know with recommenders, with things like computer vision and augmenting it with reinforcement learning. So you can take things like collaborative filtering from a recommendation perspective, that user item interaction matrix, which is that underlying concept of proximity similarity. And now you're going to augment it with that reinforcement learning diversity of predictions, and using that, the idea of how you're going to do box layouts or lists or search to make sure that you have a richer interaction. Now, in the end of this, I know I have 1 minute left. I have a bunch of notebooks that I built for you in each one of these different examples, so I have my GitHub in there. But I encourage you to go take a look at these real-world examples for your industry. I tried to put one in there for, probably 6 or 7 different industries to allow you to calculate out some of these concepts that we've been talking about today. But if you take away nothing else, I think if you, take a look at your recommendation engines, most of you probably have them in your usage today. Go ahead and think about how you can take those recommendation engines to the next level by doing things that say, instead of just showing existing recommendations, instead of just showing these existing features that we believe are driving market basket or whatever we're trying to recommend, let's look at the potential outcomes of these as an A/B test without ever having to actually run them, and then leverage that to be able to have more of this idea of what they call counterfactual evaluation, or this inverse propensity score, so that you can do more of a what if, to say, if we're going to implement this market basket and we're going to actually place content in different locations, what is that going to yield for me? And that's where having this will take you to that next level of, recommender 2 on steroids. There's a GitHub repo, and I thank you very much for your time today.
Laura, riveting as always. Does anyone from the Zoom class have a question for Laura?
If you'll all say hi to my son, just wave.
Hello. What grade is this?
6th grade.
6th graders learning about reinforcement learning.
And he's learning Mandarin, and yes.
Yes,
so
that's awesome. Great. Thank you, Laura.